Thank you, everyone.
No, let me introduce them together.
Sure.
So, Luca Cipriani, who heads the cloud backend development in Arduino, does a lot of things. We met at the coffee machine.
Yeah, a couple of years ago.
A couple of years ago, and I said, maybe one day you will work with us.
And it was true.
There you go. So hang out at coffee machines if you can. Gianluca Varisco, who is an internet superstar and expert in security. There's way too many things to say about your, okay. So I'm not going to say anything. That's okay. Apart from the fact that you are the Chief Information Security Officer, the two of them are going to be talking about the work that we're doing on IoT.
Yeah, thank you, everyone. So, thanks everyone. This is something we started thinking about really many years ago. And a lot of also competitors starting thinking and developing ecosystems around IoT. But obviously, the history of Arduino is all about making things effective for users. So it doesn't really always make sense to add feature and more feature to something that already exists, but we want to make it available for everyone. So what we figure out is that it was, and still, it's not easy to develop on your own an IoT application that is secure, reliable, and fast to implement. It's really a hard problem. We tried by ourselves. So using other clouds, you have to look around. The documentation is usually very complex. Most of the time, maybe you are a web developer that doesn't know the hardware so well, or the other way around. So you know the hardware very well, but you are not an internet expert. Obviously, in the word IoT, there is Internet of Things. So it is really hard to be expert in both worlds. So we try to simplify all of this. And more in general, the IoT is made by hardware, software, and data. And the hardware, obviously, the world is made now by electronics. We have it in our pockets. We have it everywhere. I'm using a microphone. Those are the slides running on physical hardware. So it's really a huge ecosystem, and it's very hard to program in generally. Obviously, if you don't use Arduino or similar tools. So you have to know C, C++, even more exotic programming languages. You usually have, for doing IoT, gateways in the middle. So, the hardware complexity is really hard to manage. And then there is the cloud, the I in IoT. The cloud, as it is, it can mean a lot of different things because there are really many different languages, many different protocols, HTTP, CoAP, MQTT, whatever it is. A lot of different libraries in Java, JavaScript, Python, C, C++. Everything is extremely complex. This is a programming language. This is named brainfuck programming language, and it's actually executing real code. The programming languages can really be very hard to understand for people. And then there is the last, but also most important part of IoT that is made by data, because when we start developing an IoT application, it's because we want to solve a real problem that we have. Sometimes it's even funny to do that, but mainly it's because we want to solve a real problem that people have. So really understanding your data and give them a meaning is your goal while doing IoT application. Then if it's going to be simple, easy, and eventually even fun, the better. Because we are going to solve our problem and also enjoy solving it. So to give you an overview of the complexity, those are all the vendors in 2018 that have some solution around IoT world. And actually, Arduino is one of the few ones that is here and also here. But as you can see, it's extremely fragmented landscape. So there are really too many vendors, too many protocols, too many languages, or even applications. It's extremely messy. So this is our idea, to make complexity simple to understand, because we are humans. It's fine if a machine learning system can speak with another machine learning system, but the main thing is that we are human beings and we need to understand our software. And we need to understand complexity and make it simple for everyone. And even the overall idea of the hardware in Arduino is made around the concept that if it is simple for novice people, then if you are a pro, it's going to be extremely fast to use. It doesn't mean, so hiding the complexity doesn't mean that you can't do complex thing. It just means that it's going to be extremely simple to do if you know what you are doing. So we developed this kind of, what we call it, Panini concept. The idea is that you can create your own IoT application and hardware as if it is a sandwich. Why? Because, to make great sandwiches, eventually everyone has the good the good components, let's say, the stuff to make a sandwich. The real problem is the right recipe. So we try to use this analogy to say, look, you can have your own custom envelope and your antenna. Then you can have a carrier board that is like the foundation to let your hardware interact with the external world. Then you have the real system that is making the computation, that is our boards, basically. Then you decide if you want to add more capabilities, different sensors, or like GPS, if you want to different kind of communication like the canvas or many others. And then you create your own product, which is your own sandwich. And then eventually, after you created your own sandwich, you can sell your sandwich. So everyone knows how a slice of cheese is done. What is really hard to do is make great sandwiches. So those are, the slice of cheese that we have. We already spoke about them. But the idea is that each of them has a different flavor, okay? So you can either use GSM, narrowband IoT, or LoRa. Really doesn't matter. It's up to you, because some love spicy food and some others don't. It's okay. So pick your best one and just stick to it. Then I can add more pepper or salt or whatever it is, so I can add more features to my sandwich. And those are the new shield we just announced. And finally, I can glue them together with some mayonnaise or ketchup and add them on top of a carrier board. It's like the salad in the sandwich that glues everything together. And then I can start eating it. Eating it means that I can buy even a sandwich made by someone else because I just like it. This is one of our sandwiches. It's a LoRa gateway. You can see how it is being used actually out there in the official event by a company making tractors. So they really made a real application to control and also gather data from the tractors in the field and then send them via LoRa and the LoRa gateway to our servers for further analysis. So this can literally save human life, because if something happened to the driver and it's going to go to, not in the right path, we can have an alert system and stop the tractor whenever it is. This is extremely powerful, but also, enables really saving life, but that means more in general, solving real life problems. So it's not just about being passionate about electronics or programming. It's about solving real-world problems. Now I'm going to introduce our idea around the IoT application, because we have seen the hardware, and Arduino is in the hardware field, I think, already in the last 12 years, maybe even a little more. And now we are going to enable the next phase with IoT. Our idea is that you take a lot of paninis, of sandwiches, and then you make them available to people remotely. This is really hard in analogy, you know, it's like shipping paninis somewhere else. But so I'm going to stop the analogy. But the idea is that you can really serve those sandwiches everywhere in the world and then understand what your users are doing with the sandwiches, and also allow them to create something that is much more powerful than just eating something. But in general, to create something like this is extremely complex. It took us more than 2 years to make it properly, and we still have to, you know, improve it. But now you have all the components. You have the hardware. You eventually have edge Linux devices. Then are going to speak to our own cloud that can also speak to other clouds. So if you have your own cloud or you are using third-party clouds, it's perfectly fine for us, even better, I would say. Why? Because obviously the history of Arduino comes more on the left side of this slide, no? So, you know, Arduino made a lot of hardware, but also firmware development, as we had just seen in the Massimo's presentation. We are able to automatically generate the code for you, but obviously your business logic, you are the one really solving the problem. It's not us. And then the real challenge is to make everything secure, because it's extremely easy to connect something to the internet. The problem is, as soon as you do that, someone else is going to spy it. So we want an easy way to make it properly without making it too much complex. Also, the idea is to let you manage your IoT devices, which is another challenge. Then we are going to create an interface for you automatically, and to automatically let you communicate with other boards. Why? Because Arduino doesn't make money on top of your data, because you know why? It's your data, not our data, okay? So we don't even know what you are transmitting. Our real reason of existence is to help you solve your problem. We don't want to resell your data to someone else. To be a little more in detail, as I said, we have the Arduino hardware. We found a way to automatically create proper certificate and encryption keys. Then there is an automatic generation of your code. You can change your business logic. Then you can upload your firmware on your device. Obviously, in the future, we are going to also support over-the-air updates. And then we want that all of those are going to be automatically connected with our cloud, and we create an interface for you. So from now on, Gianluca is going to give you much more detail on this new platform. Thank you for now.
Hi, everyone. Good afternoon. First of all, I'm going to talk about the out-of-the-box experience that we are actually trying to implement and include in all our products. So Arduino has in mind to make it as simple as possible, also for non-IT people, as you know, to make it like to have the experience that doesn't require IT skills. So we want to make it in a way that it's the simplest possible way for humans. Now, when it comes to managing edge Linux devices, I'm not sure everybody's aware that we have a device manager within our Create platform, and you can also manage through our Arduino connector a lot of Linux machines. So you just install the connector on your Linux machine, and then you get it started. So you get BeagleBone, Raspberry Pi, app from Intel. So you can run Arduino code also on non-Arduino boards, so straight on your device. Now, when we talk about clouds, we're usually familiar with clouds where you host stuff. In our concept, we changed slightly the idea behind it. So why don't we do bidirectional interaction with the sensors or with the devices? Now, let me get it straight. To make it happen, we also wanted to make sure, following our philosophy, that we don't lock in the customers, so we don't lock in the users. So we developed an open IoT protocol on top of all existing protocols. We don't mind if you use co-op, if you use MQTT, if you use HTTP, none of them. So you can use them all. You can use the one you want to know, and then we will translate the payload, so the traffic going through in our way. Then the application protocol, again, we're using on top of SNML and the flexibility. We do want you to focus on the logic, not the underlying platform and application. Now, imagine a greenhouse. A greenhouse is made of a fan that controls humidity sensors, a light sensor or a light physical device, a light bulb, and a moisture for getting the humidity and so on. So now, this is how Arduino IoT Cloud looks like. So you've got to define the property. So let's say fan, the type of the property, status, percentage, lumen, or float, then the way you want to interact with it, so getting an update, so getting the last value, or polling the data every second, and then you won't believe it, that's all. We will convert, so that's the usual Arduino code syntax, no? You're probably familiar with it. So you define the variables, so the so-called properties within our cloud, the light, pressure, humidity, temp, UVA, UVB, and so on. And then just look at the function, so at the method up there, Arduino cloud.update. That's where the magic happens. So we will translate everything you do locally and push it to the cloud with just one line. So that's, I think, what's extraordinary about this. Now, the same happened with actuators. So you can make callbacks. Like I said, bidirectional interaction with the devices and the sensors. So you can manage actuators out of your cloud. Let me give you an example if this works. That's the demo effect. I think it got stuck. Dun-dun-dun. I'll probably need to go without slides. I think this broke somehow. I'm actually waiting for feedback down there. It's gone. That's okay. It happens all the time. So in the meantime, let me get one message straight out of this. So everything that you are listening today about, maybe we're getting there. Okay, so I will continue later on. So about the data, we want you to make it in a way that you can display and analyze data and focus on your business and not the code, not the platform itself. So just work on the logic, we will take care of the rest. Good, it works. Now, we are Arduino, so we like also to make it fancy. We don't want ugly dashboards, ugly widgets, and so on. So we are actually making very easy to add new widgets within your thing, so within your objects, within your, like the greenhouse. You will see in a moment how the widgets look like. So also, imagine how cool it would be to be able to share your dashboard with other users. So just a link, some permissions, and share them in a secure way. And then, of course, mobile. Nobody usually cares about mobile, but we do. Now, this is how it looks like. So simple widgets, look at the fan, bidirectional actuators, off, on, humidity, just collects the data, light bulb, pressure, temperature, and so on. So that's the way we're going to visualize the data for you. And actually, you can also interact from the dashboard back to your device. Now, as I said, we don't want to lock in. We don't want to make lock-in in any sense. So we're actually also providing webhooks. Webhooks provide a simple way to interact between the Arduino cloud and commercial clouds, or let's say any kind of cloud or any kind of webhook potentially that you could work on. So you will see that this is a good example that I want to show today. So we have a webhook defined, and that's going to be a webhook on Google. Now, you can imagine already, we have a set of properties. What can we want to do? So we want to push the data from our cloud to Google Spreadsheets. So you get the data, and then you can do fancy stuff out of Google Sheets. So you don't need us to do any graph on your behalf. You can do it on your own. So you own the data, you can extract the data, and then you can also interact in between our cloud and commercial or other clouds. Now, security, that's what I'm here today for. So as you can imagine, the S in IoT stands for security. Long story short, usually there is no security in IoT. Now, we want to make it straight in every layer we're actually working on. So hardware, software, data, and what I miss here, and I feel ashamed of this, is people. Now, security is about 4 key pillars in our mind. Device identity, understanding that the board is legitimate, so that there are no fake clients simulating the traffic or putting in the middle between the device and the traffic we're going to send back and forth to us. Anti-tampering, make it in a way that nobody can alter the content of your, let me say, sensitive data or sensitive keys in that sense, and we will get there later on. Key management, so we generate, as we will see shortly, private keys, X509 certificates, so a private key and a public key, and we want to make sure that nobody can steal from you the private key. Actually, the anti-tampering, and the way we use it for key management, makes it also very secure when it comes to physical attacks, so some sorts of physical attacks. And then, of course, like Luca mentioned, encrypted transport back and forth and data confidentiality. Now, all this magic happened because of this little piece of hardware. So that's a secure element from Microchip that we use. Now, secure element open a broader set of opportunities that we are actually still exploring. At this given time, we heavily invested on putting on top of our MKR boards a security crypto chip, so the 508 and 608 from Microchip, as I said, and we actually use it for 3 main things. The hardware-based key storage, so we store the keys securely, read-only, so we can't do anything but to read the public key, but we can't even read the private key. The hardware support, so we offload all the load, so the so-called, you've got CPU load, you've got all kind of loads. We do it in the cryptographic chip, so we do sign, verify, and key exchange in a faster way that would be otherwise, and then for generating random numbers securely. Now, usually these kind of things might come in the black box, so you people don't know what's going to be underlined. We wanted to change this paradigm. We actually released a library for the crypto chip. So if you go through these repos, they're on GitHub, they're the usual Arduino library formats. There is a library for the 508 and 608. That's the library we use to communicate back and forth with our chip. We had to do a tiny, lightweight, but powerful port of the SSL TLS stack. So we couldn't use OpenSSL straight on. We had to rely on something that made us this implementation available and fast. And we choose BRSSL. So that's also on a library available as usual. And then we got an MQTT client for sending back and forth messages. Now, when it comes to the encryption, we actually have to protect a couple of things. One is the transport. And for protecting the transport back and forth, we choose to rely upon industry standards such as TLS. Then we do have device authentication. If you are familiar with this kind of clouds and with this kind of devices, usually device authentication comes in the form of username and password, or if you're lucky, tokens. So we wanted to cover both. When you connect to Arduino Cloud, you connect in a secure way with X509 certificates. So we do a provisioning that I will show shortly, and we actually just communicate with the crypto chip to get the keys and to interact and make the handshake happen. But we also wanted to make it possible for our MKR boards to work with commercial clouds. So starting in a couple of weeks, we do also have JSON Web Token support. Some of the commercial clouds are still binded to, well, actually not still, but they do like to work with JWT tokens, so we had to support it. And of course, we try to make sure that we use strong encryption. So elliptic curve on one end, and AAS CMAC in the case of LoRa. So do message exchange in a secure way. Now, just to recap quickly the amount of things I said this afternoon. So we focus on hardware-based security with a lot. We focus on device provisioning straight on. We focus on TLS certificates for authenticating and authorizing devices. And we want to make sure that your data and the data transfer underlying is secure and encrypted. Now, this will never work. I'll try. So the video should start. I'm going to show you I'm going to show you quickly how we do provision. That's very fast. But how do we provision a device on the Arduino Cloud? So that's the provisioning guide. So you're going to connect the key, define a board. Then once you configure it, we're going to burn the certificate and the private key on the crypto chip. Once it's set, I'm going to be very fast. Then you define a set of properties. In this case, it's a switch, so on/off. But I want you to show, and I will stop talking now, how easy is it. So you get pre-generated code on your browser. So you can define variables. You can edit the code. Then it goes slow. Now, being on the cloud and being with Wi-Fi connectivity, for instance, we have a tab, a so-called secret tab, where you can define your Wi-Fi network or your company Wi-Fi network and the Wi-Fi password that will be saved securely on our cloud. Then you push the code on the board, and then you can go back to the IoT cloud and you're done. So the usual way of coding within Arduino devices, just with cloud capabilities. So look at this now. You've got this, and you see, that's where the magic happens. So really, it's going to take you 1 minute. I invite you to give it a try tonight, if you have nothing better to do. You're going to love it, and we would really love to get feedbacks. I mean, we launched this a couple of weeks ago in open beta, and we would really like to collect feedback and make it better. If I can get back the slides. That's where it breaks. Anyway, I think the last slide was, thanks for attending this. If you have any question, me, Luca, and the whole team will be around the whole day. So I'll be happy to answer any question that you might have. Thank you very much. And last but not least, we also made tutorials available on our website. So if you go to Project Hub, now it works. So if you go on Project Hub, you get a getting started guide on how to use our Arduino Cloud. You get how to connect with the AWS IoT Core and the Azure IoT Cloud, and also how to interact with webhooks, like I showed before. And there's a new one that I couldn't announce today, but I can make an intro about. We're going to also support Google starting next week. So you're going to have a tutorial on how to interact between Arduino boards and the Google Cloud Core. That's really all. So thank you very much for this.